Shane, Sumondri, Jamie, David, Leia, José Cabrera, Kiana, Karim, Giselle. Guys, I don't like this environment. I like this grid view. Sorry, don't touch this. Fernando, Samisha, Daniel, Jonathan. Okay, I copy everything. So when you get in little by little, I copy my piece of paper. The attendance. Just in case, I'm checking when the class is over, because in the background of the sky, I'm recording your name. Okay, what is my plan? Listen carefully. Today I suppose we are doing something about the rational functions. My pretension is try to finish, but I suppose no. However, we continue Monday. This part plus the last part is super short. Now Monday for sure I will send by email. So this email contain the link with the Skype. I attach the review package for the test number 1 and the reading test. So you have time. Remember, I want in one piece of paper, you answer the question, show me the word in detail. You convert to electronic format. I don't know, see a scanner or application PDF or picture. And you send me back. I suppose that this weekend you are working in the homework. Remember, we have 3 homework. And if you dare, no. So now Monday you receive the reading test. I suppose that Wednesday we finish everything, and then the due date for the reading test will be next Monday, no? Okay, let me see the calendar. Putting off the microphone, please, Eric. Off. For the calendar I saw. Okay, we are talking about 22nd. I will send the 2 packages, the test, the reading test, and the package review. 24 we finish everything, and 29 is do the reading test. Clear? However, the online test, well, depende, no? I set up in the Alex May 24. But if you want, why not? I extend it to the 29. So you see, I do not extending, please remind me. You email me. Shane is expert doing this. You remind me. The professor, you can extend the 29. The 29, yeah, that's it. 29 is the last day for the chapter 1. If for sure we start chapter 2. Okay, do you understand? No question? Super clear? Like a water, crystal clear? Okay.
Okay. So the written test will be due on the 29th?
Yeah. And I need to change, I suppose, in the Alex. But you remind me, Shane remind me. Or another student, doesn't matter. And let me know if you see my whiteboard. There you go. Do you see? Do you see?
Yes.
Yes, cool. Okay, what is the idea in the first part? In the first part, I want to cover, to explain theoretically The vertical asymptote, we have three kinds of asymptote: vertical, horizontal, and slant. So I want to introduce example, but short example, in which I illustrate the part I want to introduce. After that, no. After that, I put everything together. So I bring 3 or 4, I don't know, more examples of the completed big picture. Okay, so now, bueno, es easy. I recall que the rational function is a new function that we are studying, que is the combination 2 polynomials. We have one polynomial in the top, que normally I call P of X, y one polynomial in the bottom, que es Q. I don't know why it's a notation. But in this specific example, P is the degree 0, no? Because I don't see any variable here, x to the 0. You suppose que es x to the 0, but this is invisible, no? And not necessary to write this stupid idea. However, the degree of the polynomial at the bottom is 1, it's linear. Okay, cool. Now, my goal right now is determine vertical asymptote. And vertical asymptote, by definition, is one value of the x such that the function to be undefined. So go to infinity positive or infinity negative. This is the definition of the vertical asymptote that we discussed last time. But this is easy. You take the polynomial at the bottom, that one, and you enforce it to be 0. And you solve for x equal 3. So in x equal 3, we have for sure a vertical asymptote because it's logical. If you try to evaluate the function in 3, you have 2 over 3 minus 3 gets 0 in the denominator, and you know what happened when this 0 the denominator gets to be undefined. Okay, you don't need to prove this. No, you only take the polynomial in the denominator, you enforce it to be 0, and you find the solution, the zeros. Okay, now, but the problem is that we have 4 kinds of vertical asymptote. To determine that, it's easy. You evaluate, so this is my asymptote in 3. You put a dotted line, vertical dotted line. Okay, this equation is equation x equal 3. And you evaluate a little bit, of course, closer to 3, but to the left and to the right. I suppose that I select 2, yeah, I select 4. Or one other value, 5 or 6 or 1, but I prefer closet. And you evaluate into our function, and you evaluate in 4 our function. Entonces, 2 over 2 minus 3, que es negative 1. 2 divided by negative 1 is negative 2. Then, in 4 is 2 over 4 minus 3, que es positive 1. Entonces, 2 over positive 1 gets 2. So actually, I discovered that the point 2, negative 2 belong to our graph, and 4, negative 2 belong of the our graph. So now here, in order to don't go to the decimals, so we lost time, the connection doesn't work. I make a screenshot for this example today, no? And so this is our, this is our, don't worry. Let me Control Z to undo this operation. Now you see the symbolic representation for the vertical axis is vertical line, but dotted line using black color. And the curve, I don't know, I using blue. Yeah, I plot the point. Again, this case 4,2 and 2, negative 2, exactly the same. And this is approximately, you know, one first approach it to see how it look like my rational function. Any question? Do you understand this or no?
Yes, I have a question.
Well, suppose I ask you, what about what is the domain of that function? Domain. Well, domain is all real number except the bad guy, the bad guy is 3, no? So, there are many ways to represent this idea, but one fantastic idea and easy is x such that symbol is such that x is not 3. So in conclusion, is all real number except positive 3, because I know very well can positive 3 our function to be undefined. Okay, that was the first example. Super easy.
So I have a question.
Go ahead.
How did you get 4?
Well, arbitrary. Okay, look, I get 4, pick arbitrary value to the right, maybe 4, maybe 5, maybe 6, arbitrary. I need to make a decision, so I pick 4, and to the left I pick 2, or 1, or 0, okay? Because I want to know the behavior. Look, this is the asymptote. I pick here, you get positive value. You pick here, you get negative value. So now my asymptote look like that. Fun. Make sense?
Oh yeah. So correct me if I'm wrong. So we're picking random points on the
answer doesn't change. You pick another value. Suppose you pick 5, and you get that value. You pick 6, you get that value, and so you pick 1, and you get that value, get negative, of course, and you pick 0, and you get this value. So I pick totally arbitrary value after the asymptote and before, to the right and to the left. Remember, the reason is because we have different behavior of the asymptote. One asymptote is like that, another asymptote is completely different, it's like that, another asymptote is like that. I don't know if you remember in the last class, another asymptote is like that. Okay? Was clear now or no? Mister, answer me.
Yes.
Okay. Example 2. A little bit more interesting. Wow. Okay, no problem. You are here. Es the function g que es equal x minus 3 over x squared minus 5x plus 6. Okay. We have a rational function. In the top, we have one polynomial degree 1 linear. And we have in the denominator another polynomial degree 2. Now, I want to explain in detail after. No, now. What is the importance of the degree in the top and degree in the bottom? But so far, it's okay. Now, immediately, the first thing you should do to analyze that kind of function is express it in factory form. Factory form. Case, of course, factorization the polynomial in the top and factorization the polynomial in the bottom using the classical technique of factorization or using the sophisticated scientific division. No? Either way, the x minus 3 is impossible. Break it down anymore. It's just a binomial. However, the trinomial, yes. The factorization is 3 and 2 because 3 times 2 is 6 and somehow 3 plus 2 is 5 and negative both. Now we see, wow. We have 2 factors cancel. I cancel. And you get equivalent, case 1 over x minus 2. Entonces, I explained the last class. The factor que es cancel is considered like a wholes. I suppose that today you understand very well what is the wholes. So the whole, we have the whole at x equal 3. Okay, of course, is completely out of the domain. But however, we have another case at x equal to, very similar to the example 1, que es the binomial que stay in the denominator, but in this case, no whole. It's a vertical asymptote. There are 2 reasons. See, I asked you, for example, in the test, what is the domain of G? Well, the domain of G is all real number except two bad guy, positive 3 and positive 2. So it's x such that no 3, comma, no 2. However, if you want to represent the graph a little bit approximately, not too accuracy, but approximately, you evaluate the function g and two arbitrary values before and after 2, que es de asymptote. Suppose que I pick 1. Okay, this is my all real number line. This is 2, and 2 for sure they are vertical asymptote, and 3 no, and 3 we have holes. I don't know exactly how to represent the hole. Let's see now. However, I pick one guy, okay, maybe 1. I evaluate the function in 1. What function you can evaluate? The original, or the new one, the new one? They are different, they are equivalent 100% or no? Well, the answer for this question is clear. This is equal this. Equal this under the consideration that you never evaluate in 3 and x not 3, because in 3 we have a hole. Okay, if you want to evaluate in 1, to say my opinion is easier not using this long horrible expression, not using this is easier. And you evaluate 1 over 1 minus 2 is negative 1, to say 1 over negative 1 is negative 1. That point is the point 1 comma negative 1. Okay, no problem, I understand. Now I'm going to find another you evaluate after the asymptote, que es en 2, pero en 3 no, because in 3 is defined as a whole, and you evaluate in 4 maybe. Let's do it. G in 4 is equal 1 minus 4, no? A ver, 1 minus x is, no, es, sorry, 4 minus 2. So you plug it in here, replace x for 4. Let me erase here. It's 4 minus 2, que so because 2 is 1/2. Therefore, my point would be 4,1/2. Well, okay, with this information, I know 100% information how it look like, but I have roughly approximations. Let me try. Try. Now, let me see where I put the image. I suppose it's this. Is it this or not? Oh yeah. Look at that. Let me make it zoom to see more clear. Then we have one asymptote. Let me enlarge this, que es en 2, 1, 2, asymptote vertical. Entonces en negative 1 is down, is negative, cool, and positive 4,1/2, que is approximately 4,1/2. Very important now. Let me make it zoom. You see the representation of the whole, que es a circle open. That means que the original function, when you try to evaluate at x equal 3, the answer is not 1. The answer is undefined. 1 is the answer when you plug it in this expression, in this one. So es 1 over 3 minus 2, que es 1. Y 1 divided by 1 is 1, so this point is the point 3,1. But in the original, this point do not exist because it's a hole. Do you understand very well the idea of the hole or no? Yes or no? Come on. Clear or confusing? Super clear? Yes.
That's clear.
Okay, do you understand very well? Vertical asymptote, okay, in few words, I can say. You factorization, the polynomial at the top, and you factorization the polynomial at the bottom. If some factors cancel, that factor gets canceled as a whole, and you consider in the graph like a small circle open on the curve, of course. And the factor can stay alive in the denominator is a very constant. And you, in order to understand a little bit what is the behavior, you evaluate in before the asymptote and after, and because you want to investigate the sign, no? Positive, negative, positive both, or negative both, doesn't matter. Okay, let's move on to the horizontal asymptote. Horizontal asymptote is a little bit more complicated. But no, because you are familiar somehow with the end behavior of the polynomial. Actually, horizontal asymptote is like an end behavior. Horizontal asymptote is, bueno, is you investigate what happens when the x is a huge number, maybe positive infinity or negative infinity in both directions. And you investigate what value of the y or f of x. And you approach. You approach it to one value, I don't know. So you approach it to one value d. Entonces now we have horizontal asymptote because horizontal asymptote is a horizontal line. A horizontal line is a line, it has a zero slope. So the equation would be y equal d, no? And d represents one number. You see now in the sample 4, 3, 20, doesn't matter. And how do you know that? Well, there are several possibilities. I want to explain one by one in detail. Look. To investigate the horizontal asymptote, we need to do the degree analysis. Degree analysis. What is that? So it's very, very easy to understand. You say examples. Theoretical, no. Examples. For example, example number 1 for the horizontal asymptote. Suppose that we have one function f of x equal 7x squared plus 2x, and the only one doesn't know see what he is reading. Okay, please indicate to him what he should do to see my Gutierrez. I can't see either. Everyone saw the whiteboard or no? I can see. Shall I know?
I think it's frozen.
Yeah, me too. I see what I see what you wrote before, but what you're writing new, I don't see it.
Okay, let me try. Let me try. Okay, I stop sharing. I want to share again. Switching to Microsoft Whiteboard. Now you see? Oh no.
Yes.
Yes, we see.
Okay, I fixed it now. I delete the share command. Yeah, I again open. Switching to the whiteboard. Okay, so we continue. Mister, you see or no? Everyone saw? Yes.
Yes.
7x squared plus 2x. This is just example. Let me try to understand this example. Suppose we have these rational function. Okay, by the way, the degree of the polynomial in the top is 2, no? And the degree of the polynomial in the bottom is also 2. Wow! So when the degree, when degree, let me use in this notation. D indicate degree of P. Okay, P, by the way, is always the polynomial at the top. It's a P. And it's a Q. I need to call some name, no? To reference to this. Si it's the same degree of Q. The answer is then, yes, we have. We have what? Horizontal asymptote. But this is not enough because you need to understand at what value. Entonces, to understand what value is super easy. Look, you apply the same idea of the aim behavior expression. Aim behavior expression. And the aim behavior expression of the polynomial at the top is 7x squared. Remember, aim behavior, you take the greatest exponent, no? It's 2. And the bottom is 4x squared. Yeah, you ignore, you consider negligible this guy and this guy. And make it sense because the consideration of the horizontal is that x is infinity or negative infinity. In other words, it's a huge number, positive or negative. So now 2x is nothing. And minus 3 is super nothing. And you take the dominant expression. So now when you see the dominant expression, specifically in this example, you see the x squared is cancelled and stay alive only 7/4. Another easy word. When repetition again the idea, when you investigate and you are doing the analysis of degree analysis. See, the degree is the same. You take the leading coefficient, so coefficient in front, the dominant term, okay, 7 in the top and 4 in the bottom, and this is my horizontal asymptote, 7/4. So when I finish the graph of this, no, now we are doing another more complicated example. When you finish that, I suppose that we have in the curve, I don't know, no idea now. No, I don't care. I don't care. This is not the moment to analyze this. Because you try to analyze everything together, it's crazy. We have horizontal asymptote. This is horizontal asymptote. And the curve, I don't know, approach it, but never touch. Okay? Okay, something like that. Let's do a couple of the example, and you help me to understand this. For example, example 2 and example 3. Okay, entonces the function is h of x. The polynomial at the top is 8x squared plus 9x minus 5, 2x squared plus 1. We have another example that p of x is equal x squared plus 7 divided by 11 minus x squared. What do you think about number 2? We have yes or no?
Yes.
Yes. The reason is clear because the degree is 2 and the degree is 2. Same degree, yes. My second question is, at what value? At y equals something.
Eight over 2, which is 4.
Exactly. 8 over 2 is 4. End of story. Super easy. You take 8, you divide by 2, is 4. Entonces, example 3 is similar, but a little bit tricky. I put something to confuse you. I suppose that I don't confuse, but because it's similar. Okay, the answer is yes or no? We have
Yes, right.
Yes, right. Because the dominant is this in the top, and the bottom is the dominant. I intentionally write in different order to confuse you. But you see, wow, it's the same degree. Hello. At what value? At what value? The asymptote is located at what value? At what value? At y equals
7 over 11.
No, remember this guy is totally negligible. You take the dominant, que I put in blue color. O sea, the dominant es negative 1. I know que es tricky. I put intentionally to confuse some students. Okay. The monomial que have greatest degree is the dominant. The other you ignore. Si es the same, yes, we have our value at the division ratio. And between that coefficient que es 1, positive, and this coefficient que es negative 1. 1 divided by negative 1 also obvious que es negative 1. Okay, I understand. At least I understand. I don't know if you understand. Everyone understand? Everyone follow me or no? Confusing?
Yes, and this is for the horizontal asymptote?
Yeah, it's a horizontal asymptote. We are doing Mr. The degree analysis. And the degree analysis, you analyze what is the degree of the polynomial at the top and what is the degree of the polynomial at the bottom. However, I don't finish. We have another case and you need to memorize this. Okay, listen. This is just the beginning. Okay, suppose another scenario. Suppose example 4. Suppose example 4 is f of x. Okay. Share it. Okay. This class is amazing. Everyone follow me. F of x is equal 5 over 4x squared plus 9. We are in front again one more time of the rational function. It's the division to polynomial, okay? But the degree of the polynomial p is 0. And the degree of the polynomial q is 2. Entonces, this is like a special case. So in the horizontal, we have 2 cases. The regular, que explained at the beginning, is when they have the same degree. However, we have a special. Okay, special is when the degree of P is less than, no equal, less than degree of Q. Entonces, the conclusion is then, yes, we have horizontal asymptote, but in this case, is at y equals 0. And this is logical, because we have the competition to polynomial. See, the polynomial Q increasing faster, because the S degree 2. Suppose degree 0 is a constant, stay the same. However, degree 2 is a parabola, increasing faster. So if you are doing division and between 2 numbers, and one number stays the same, 5, 5, 5, 5, 5. Another number no, increasing. 1 million, 1 trillion, 1 quadrillion. Entonces es obvio que the division is smaller number y approach it to 0. This is the idea. So in conclusion, you have to remember, please, that we have 2 scenarios in which you have horizontal asymptote. When the degree is the same, when the degree is the same, there are no competition because it's a square. So this increasing faster and this increasing in the same speed because it's the same degree. In this case, no. In this case, this is o es constant or suppose que es x and x squared. This is 3 and this is 5. This is increasing faster, but this increases double faster. Okay? So now the quotient go to 0. Do you understand this or no? Yes, no, yes, no. Yes. Jay, say yes. And the rest of the students, yes? Don't accept anything you don't understand. Okay, if you don't understand, I try to use my best skill, pedagogic skill to explain something, right?
Excuse me. So like, let's say it was a 5x, your horizontal asymptote would be 1. because it's less than.
What is the example you want to see? 5 what?
Like in example 4. If like instead of just 5, if it was 5x, so like the degree would be 1. Would your y be 1?
No, in this case, it stays the same because degree 1 and this is degree 2. The degree of the denominator is bigger. That means that that polynomial increases faster than this. This increasing, but not too fast. So the yes, we have at 0. Exactly the same. It doesn't matter. It's like, when it's different. Oh, when you have a square. Oh, this is the same degree. Degree 2, degree 2. Therefore, yes, we have, pero no especial, sino regular, que es add y equal 5 over 4. Make sense?
Yeah.
Excellent question. Excellent question. But we have more detail. Well, the last one, I promise. In the horizontal. Sometimes happen, not always, very, very seldom happen, que our curve, our graph, somehow, suppose this is the horizontal asymptote. It's X, it's a Y, but sometimes happen, not always happen. Okay, the curve, for example, the curve approached, but never touch this. Suppose it's like that, touch. And now in continue and never touch. So sometimes happen, this is asymptotically, sorry. Asymptotically, when you're talking about asymptotically, that means que the curve approaches but never touch. So the distance is smaller, but not zero. Entonces, this is the most popular scenario is, suppose the horizontal, suppose que happen this situation. Asymptotical approach, asymptotical. This is the most popular. 99% of the time, you see this. However, you need to analyze that possibility in the horizontal. Que the Ms. Norrie, what is your question? What is your question? Activate the microphone to understand you. 9 equal 9. Equal 9 who? I don't hear you. Activate the microphone. My microphone is let me see how many percentage. 50%.
I think someone is wondering why, since in the other one, y was equal to 0, but in this one, it's equals to 5 over 4.
Yeah. The reason is because you have in the top degree 2 and the bottom degree 2. So you have same degree, you take the division ratio between leading coefficients. But when the degree is not equal, like this example, the degree 1 and degree 2, entonces 0. Or degree 0 and degree 2. So when the degree of the polynomial and the denominator is greater than the degree of the polynomial and the numerator, es obvio que es special asymptote at y equals 0. Clear? Maybe you don't understand 100%.
Oh, sir.
Right.
I think she's talking about the 9, the plus 9. She wants to know.
Plus 9 is negligible. Remember, we are talking about horizontal asymptote. And horizontal asymptote is equivalent somehow with the aim behavior. So you analyze not the function in any point. No. You analyze the function when the positive infinity, you approach it to positive infinity and negative infinity. So positive infinity is in that direction. Positive infinity and negative infinity. So what is the value of the function? In this special situation, positive infinity and negative infinity. This actually aim behavior. Okay. Maybe you don't understand very well 100% this idea, but I suppose when you are doing several examples, you get the idea because the idea is logical. It's super clear. Okay, the thing I try to discuss it now is different. Is the crossing point. This is a crossing point. Crossing point. So sometimes, not always, seldom happen que our curve que I try to do using my best skill crossed the horizontal asymptote. And this never happened in the vertical. But the vertical is, you know, it's like that. Vertical asymptote 1, vertical asymptote 2. However, my curve approaches asymptotically, but never cross or touch. Illegal. This is a violation. Impossible, because it's out of the domain. And the horizontal, maybe yes, but only 1% of the time. It's very, very weird. Seldom happen. How you investigate that? I bring one example to illustrate very well this idea. Example number 5, no? Number 5 or number, let me see. Example number 5, yeah. Example number 5 is the function y equal 8x squared plus 9x minus 5 divided by 2x squared plus 1. Okay. However, before to start that part, I want to ask something. We have horizontal asymptote, yes or no?
Yes.
Yes, you are right. By the way, you know what value is at y equal
4.
4. Excellent. So we are in the scenario regular, not special, in which the degree of the polynomial in the top is the same of the polynomial at the bottom. Nice. So the answer is yes or no? Of course, yes. At what value you take that number, coefficients in front the dominant and the top, and coefficients 8 divided by 2 F4. Okay, you understand very well this. Now, what is the new situation? The new situation is a crossing point. I want to investigate if this function is given at the beginning somehow crossing or no the asymptote. Entonces, to investigate this, bueno, you set out the expression. You copy ax squared plus 9x minus 5 divided by 2x squared, and you enforcing the situation, equal 4. You enforcing that our original function is equal the value of the asymptote. So we have two possibilities. This is the equation, we solve the equation, we finish, done. See, this equation contains solution, because it's the standard equation, yes, we have. See, this equation is impossible, there's no solution, so we have no, right? Then to solve this equation is pretty easy, because you apply maybe cross multiply. You multiply this guy times this guy, and this guy this times this guy, because I want to eliminate somehow the fraction. So a squared plus 9x minus 5, multiplication by 1 stay the same, and 4 times 2x squared plus 1. Do you follow me, guys? Do you understand the thing I am doing? This is 4.
Yes.
Now distributing. Ax squared plus 9x minus 5 is equal ax squared plus 4. Guys, this is the way I want you solve the problem in the test, in the written test, line by line. You apply something, the rest you don't touch, you bring down. It's the only way I can understand. And it's a cancel that part. Okay, let's stay 9x minus 5 equal 4. Entonces 9x is equal 4 plus 5 is 9. Divided by 9 both sides. X equal 1. Oh, yes. At x equal 1, the value of the function is coincident with the value of the asymptote, horizontal. If you want to express it, this point, is a crossing point, it's a technical name, crossing point, like an ordered pair x comma y, Es obvio que x is 1, we found in the solution. And what about y, guys?
4.
4.
Es obvio que 4. Very, very well. Good answer. Let me try to do quickly the graph of this function. Okay, I make a screenshot. I don't know, see I found or no, let me see. Okay. Is that graph, that one. Okay. Let's see. Horizontal asymptote. Yeah. Okay, maybe you don't see very well, but I want to enlarge the figure. Oh, this graph is weird. This graph have no vertical asymptote. I don't know why, but I need to understand after. However, we have the famous horizontal at y equal 4. Look at that. Let me make a zoom to see more clear. Okay, this is 5, this is 4. This is the horizontal line, horizontal asymptote, sorry, at y equal 4. And the famous crossing point is 1,4. In this case, we determine algebraically and we plot that. Don't forget, the student forgot always. When you determine the horizontal asymptote, okay, yes, no, our value, yes, I got it. You need to investigate if you have crossing point or not. You see in several examples I bring today, because sometimes we have no, and sometimes yes, we have. Any question? No?
Yes, on the written test, do you also want us to graph?
Yeah. After that, so I want to not pay too much attention now in the graphic part. Oh no, you see. If you want, guys, one possibility, how you study, look in the video on YouTube, no? By the way, I don't remember say I recording or not. Yeah, I recording. Some good student press recording. Okay, no problem. I suppose that you want to see in your computer that graph in detail, no? Yes or no? That's the idea. There a possibility, no? Because you, for example, I send to you now when the class is over, I send the link for the YouTube, but I send also the link of the Desmos, and you can open the copy of my Desmos, and you see graphic one by one that we're doing today. Do you consider good this idea? Tell me something, yes, no? Do you understand the thing I explained or no?
Yes.
Yeah, that's fine.
Okay. I don't see too much enthusiastic, no? But it's okay. Okay, let's move on to the example. Next example is I change something. This is about the slang accent. It's another. I promise it's the last one. Slam accent. That word slang is synonym asymptote of the oblique asymptote. So now, so far, the only asymptote that we are studying is vertical, pam, horizontal, pam. Now we study slang is like that. I don't know, si es, okay, this is positive slow, negative slow, this is slow 0. When it's flat, horizontal is slow 0, and vertical is slow undefined, no? Undefined, because it's y is missing, entonces x equals something, 3, 4, 5. And here, no. Here we have y equal mx plus b. It's a classical equation of the line. And this is the oblique or slant. Okay? Let me try to bring example. Easy to understand this. Look. Suppose example 1 of that part. F of x equal x squared plus 1 divided by x minus 1. Okay, one more time, we are doing the analysis of the degree. But in this case, the degree of P is 2. And the degree of Q is 1. So I remember the horizontal scenario, okay, same degree or opposite. So the degree of the denominator is bigger than. In this case, completely opposite. But not exactly. Let me explain in detail. When the degree, so if, the condition is clear. If the degree of P is greater than 1, so the degree of Q, no in general greater than, no, plus 1, so degree 2, and 1 plus 1 is 2. So degree in our example, degree Q is 1, and 1 plus 1 is 2. Entonces, yes, we have a slant asymptote. Entonces, you compare that condition and the condition for the horizontal, you see that they are mutually exclusive. No, if we have horizontal, no slant. And so you have slant, no horizontal. That is the reason in the guideline I want to explain after this example, you analyze together in one point, horizontal and or slant. And so you make a decision, well, we have this or we have that, okay? And one more time, we are doing the degree analysis, but in different direction. O sea, when the degree of the, not necessarily 2 and 1, suppose that this is 3 and 2. 3 and 2, no? Yes, it's the same idea. When the degree of the top is one more degree of the denominator, so we have a slant. Okay. Let me continue this example. So what is the equation for the slant? It's easy. You are doing division. You divide this divided by this. You are doing division. Let me delete that part. Yeah. All right. Yeah. Okay. You, for example, let me erase something here. It's not important now. You are doing the division. But what division, Professor? Long division or synthetic division? I suppose that synthetic division is better. Okay, what are the differences I want to record again in between long division and synthetic division? Long division is more general, universal, and you can divide any polynomial degree, it doesn't matter, divided by another polynomial ED, it doesn't matter, do different degree and it's working perfectly. However, in the synthetic specifically, it's a simplification, it's a shortcut. But when you divide a polynomial in the degree, whatever, but in the denominator we have linear, degree 1. This is the condition, the only condition that you have to apply synthetic division. But of course we can do that because degree is 1. So now, suppose, I'm doing the format for the synthetic division. Okay, be careful, it's tricky. This is x squared, this is x1. And this is x0. In our specific example, we have 1 here, no linear missing, and 1 constant. And remember, in the divisor, you copy 1, but opposite sign. Because this format is a factor, however, this format is no factor, is 0. This is the only detail, you need to consider. Bring down 1. Multiplication 1 times 1 is 1. 1 plus 0 is 1. 1 times 1 is 2. 1 is 1, sorry. 1 plus 1 is 2. In this case, no 0 remainder. That means that the factor x minus 1 don't belong to this. But this is the remainder. So now you write this expression is x squared minus 1 over x minus 1. You write equivalent like that. This is the remainder. This is the remainder, sorry, remainder. But that part is a quotient. It's a quotient. Of course, this one is the divisor, no? Divisor, but I don't care now. But the quotient is x to the 0 and x to the 1. So it's x plus 1. It's a quotient. Plus, and we have the division remainder que 2 over divisor que is x minus 1. Guys, this expression is equivalent 100% to this. It's equivalent, the same thing, true. However, you see now super clear that part represents the slant asymptote. Okay, by the way, is the equation y equal x plus 1. O sea, es the line whose slope is 1 and b is a y and z is 1. And you plot that. Suppose you plot that. Well, 1 is here on the y-axis at the point 0,1, no? It's a b, that b. And m is 1, so now from that point, I'm moving wrong and rise. This is wrong and rise over wrong. The geometry interpretation for the slope. Rise is positive 1 over. And wrong is 1 also, everything is 1. So now we're connecting this point and this point together, and this is the representation for the hour slant asymptote and this example. To say in conclusion, in few words, I can say that we have a slant when the degree of the polynomial in the top okay, I suppose que es this example. Let me make it zoom. Look, this is the graph of our example number 1 in the slant. In this case, I can see, remember, this is f of x equal x squared plus 1 divided by x minus 1. Okay, I investigate doing side division, que is equivalent to x plus 1 plus 2 over x minus 1. And this part is this line. This is the equation y equal x plus 1. And we have another asymptote. Yes, we have another. Because remember, to analyze the vertical asymptote, we don't need to analyze any degree. You take the polynomial in the bottom, que es x minus 1, you enforce it to be 0, x equal 1, it's our vertical asymptote, que es at 1. And the rest is the curve, que when we are doing another analysis, que is the blue curve. Super clear?
Yes.
Okay, super. Now, this is a crucial moment because in this moment you are ready to start serious examples. Okay, serious example, step by step. Because I want to show you the guideline that we are using always. We have, by the way, 8 steps. Don't worry for this. I want to explain one by one in detail. Entonces now I appreciate so much that you are doing in this order 1, 2, 3, 4, 5. Okay, what is the first step? The first step is you factorization. You express it polynomial p and polynomial q. Okay, it's the first thing. Step 0 to start. Step 1 is factorization. And the numerator and the denominator, and cancel the common factor. And the factor gets gone, gets canceled out, they are the wholes. Okay, if exists. Not always, as we are very well. You see some example, of course. But no always. Seldom happen. Okay, this is my step 1, mandatory. My step 2 and step 3 is easy. They find 2 is 2, or not necessarily 2. The inner set. So we have y inner set and x inner set. Y inner set is super easy. That's the first thing. You evaluate the function and 0. And end the story. But x inner set is more complicated because you take the function, you enforce it to be 0, and this is the analysis complicated. Okay, you have polynomial, and now you have to apply the rational 0 theorem, or maybe the Descartes rule, or maybe factorization synthetic division, or classical factorization, it doesn't matter. And you determine this point. This is a super important point that any graph needs. The x intercept and y intercept is a famous point in which our curve crosses the x. Suppose, okay, our curve look like that. So we have this point, this point, this point, and this point is the real x-intercept. And we have only one crosses the y-axis. Okay, this is this. Okay. Okay. There's a number 4, super important. Number 4, super important. Number 4 is identify the vertical asymptote. But I say it's easy because you have the rational function, have polynomial p, and have polynomial q. In order to find the vertical asymptote, you take the polynomial q and you enforce it to be equal 0, and you are doing similar idea, you factorization. This is the same idea of this, but this is in F or R, whatever. In this case, more specifically, guys, I forgot to say something, but I want to rectification now. It's better using P. Because 0 divided by any number is always 0. So the Q is not important, it's totally irrelevant in the x-intercept. You take P polynomial at the top, you enforce it to be 0, you apply the 0 for this. For the vertical asymptote, no, you take polynomial Q, case when the function to be undefined. 0 in the denominator to be undefined. I need to erase that part. Okay. Oh, yeah, no. Okay, so now in this moment, I don't know why, I like so much doing all real number line. Okay, it's equivalent to the x-axis. This is positive infinity, it's a negative infinity, and 0 in the middle. This is my way. No book specificates this idea. And you plot the information that you have so far. The information that you have so far is the x-intercept. Suppose that we have 3. Suppose that we have 1 here. You see in the example here, 1 and 3 and negative 1. But in the example 4, you taking Q equals to 0, you determine okay, we have another solution, x equal 4 and x equal -3. So now I know again 4 positive. We have horizontal baric acid, sorry, baric acid number 1. Baric acid number 1. And -3 get -2, -3. We have another baric acid number 2. Okay, okay. What is important is, Professor? Well, it's important because in the last step, is number 8, we know in the last, no, in the 7th step, sorry, we plot at least 1 point on the interval defined by the x-intercept and baric acid. So you pick how many? This is a classical question. Professor, how many points I need to plot? Well, that depends on the example. I plot, for example, one guy after the baric acid. I plot one pen between the baric acid number 1 and 3. I plot one in between 2 x-intercept. Boom. I plot one in between this x-intercept. I plot one in between, maybe it's -2, and I plot that. In this case, I plot 1, 2, 3, 4, 5, 6 points. It's a minimum value to get a decent graph of this. Okay, so you select one arbitrary, totally, and of course, nice value. No 1.5, no 100. Suppose in this scenario, well, in this scenario, 3.5 maybe. And this scenario is good as this is 2, this is -2, good, and this is -4. Okay. 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 Okay, this is no mandatory. If you like, it's my recommendation. Do the graph and you determine the point, the potential point in the future we need to plot to finish the graph, a decent graph. But you don't worry too much for this because you are doing Desmos. And Desmos, I want to show you after. No. Well. This is the most complicated part now is complicated. Step 5 is determine whether the function is horizontal, slant. So in the step 5, is determine is horizontal asymptote or slant. What is the reason? Can I analyze simultaneously this? Because they are mutually exclusive. So you have horizontal, it's like a gender. So you are female or male, not both. So now horizontal asymptote. So you have horizontal, we have no slant. See, we have slant, no horizontal. So I recommend, because it's easier, at least in my mind, analyze horizontal. Now horizontal we have in 2 scenarios. The regular is when the same degree in the numerator is equal to the degree of the denominator. See, it's the same, you take the leading coefficient, and this is the y value of the horizontal asymptote. And just in case, I need to verify the crossing point, always. Okay, cool. See, the degree is different? No, yeah, see, the degree of the denominator is bigger than, not bigger than 1, bigger than bigger. Is special case at y equals 0. End the story. This was horizontal. Slant is more picky. Slant we have only when the degree of the denominator is greater than 1, the degree of the numerator. Otherwise, no. So you, in order to find the equation for the slant asymptote, you are doing scientific division or long division, either way. And in this example we are doing today and Monday, we are doing using either way, the way you feel more comfortable. So you feel comfortable with the long division, no problema. So you feel comfortable with the scientific division. I like scientific division because it's easier, in my opinion, no? But okay, you need to remember a lot of detail of the scientific division. Okay, number 6. Okay, I don't know why the majority of the students are doing. I forgot. Number 6 is the symmetry. The symmetry. So you need to investigate if the function is even, is odd, or neither. Why is important this? It's important because so you will be able to prove que es even It's because the positive part and the negative part stay the same. So you save time because you need to understand only the positive part because I know that the negative part is the same. Let me try to explain more clear this. What about even? Even is when you make a reflection, suppose the function. However, when you make a reflection, okay, replace x for negative x, oh, nothing happened. It's the same. That means our function, this is 0, this is the positive part, is symmetric with respect to the y-axis. So my function look like that. See, this is this is that. So it doesn't not necessarily take care the negative value because suppose que that point is 1,1,2. I suppose que negative 1 is also negative 1,2, the same y value. So you save time. See, it's even, wow, symmetric. CS odd is also symmetric. This is both are special. But it's another kind of symmetry. This is CS odd. Again, we have here y-axis, x-axis. This is a typical scenario in which is odd function. Suppose it's like that, and suppose it's like that. Suppose that this point would be again 1,2. 1,2. Now, in the negative part would be negative 1, negative 2. So it's the same value, but opposite side. So the conclusion is when you perform a proof of the odd function, you are doing symmetry. You replace x for negative x. But magically happen that this negative inside the parentheses go outside the parentheses. It's opposite side. Okay, so now, well, okay, this is easy. You apply different point 1, 2, 3, 4, 5, and the other is this, but opposite side. Neither is completely not symmetric. So you prove that neither, there are nothing to do. So you need to do the positive part and the negative part completely separate, independent. It's different part. Okay. So it's good to have symmetry, no? Because you save time in the plot. And finally, well, you put everything together and plot the point. Let's do it in one example. The first one. The first example. The first example. The first example. The first example. Okay, only, yeah. Let me try to find one space in my whiteboard. Okay, this is delete, click, delete. Okay, this is my first example. Pero completely doing the guideline. Step 1, step 2, step 3, step 4, step 5. It's exactly I want to see in the written test. By the way, in the written test, we have 2 graphics of the ratio. 2. But no big deal. Super elementary. Super elementary, no, regular. No sophisticated. Suppose this first example. That one. Example, serious, example 1. F of x equal 4x over x squared minus 4. So let's do it step by step. Because you are doing totally disorganized. Maybe you forgot something. Okay, so step by step, you have the guideline. If you want, I send the guideline in one piece of paper. Okay, you print or I don't know. And this allows organization of the work, number 1, and number 2, don't forget one step or one piece of the step because the different steps have different pieces. So now, step number 1 is factorization. Step number 1 is factorization. Okay, so f of x and factor 4 is in the top, there are nothing to do. And in the bottom is the famous difference of a square. Plus or minus. End the story. I finish step 1. Do you follow me? Do you follow me?
Yes,
Say
yes.
Yes. Step 2. Yes, Gustavo. Step 2 is find a y in a set. Bueno, y in a set is easy. What is the formula, professor, to find? Bueno, you evaluate 0. So you take the original, and substitution, replace x for 0. Es obvio que 4 times 0 is 0. 0 squared is 0. Minus 4 is negative 4. But 0 divided by negative 4 is 0. Therefore, the conclusion is the y-intercept is located at the point 0, 0. This 0 is x value, is this. And this 0 is y value, is this. So the origin, 0, 0, is our x-intercept, y-intercept, and also sometimes happen, not always, but happen, there are coincidence, is also x-intercept. But sometimes no. Sometimes we have another more. So remember, it's a polynomial, and the polynomial 1, 0, 1, 0. The polynomial is 0. But we have another 0. We have 2, 3, 4. So several 0. So just in case, I need to analyze step 3, que es the x-intercept. And the x-intercept is easy because you take the polynomial p. I want to copy the symbolic way, but specifically in our example, polynomial p is 4x. 4x equals 0, divided by 4 both sides. It's obvious that x equals 0. Confirmation. The 0, 0, xy is both. It's x-intercept and y-intercept. We have only one. Not 2, or not 3, or not 4, depending. Depending on the examples, we have several. So far, everyone follow me? Step 4. Step 4 is the vertical acid. The vertical acid is easy because you take the polynomial q, que es the polynomial in the denominator. But there are two possibilities. Entonces, one student says, well, no, professor, I prefer that way. The original is given at the beginning. Okay, I respect. You copy x squared minus 4 equals 0. You have quadratic equation. Solving this quadratic equation, and the easy way is by square root method. You move 4 to the right hand side, apply square root both sides, and x alone is equal plus or minus 2. So we have two vertical acids. Vertical acid number 1, vertical acid number 1. Doesn't matter, no one who call 1 and 2 is totally irrelevant. Positive 2 and negative 2. Another student said, no, I don't like this. I don't remember what this. I prefer, you are actually doing the factorization. There are no reason to solving the quadratic equation because you break it down into linear equation. X plus 2 equals 0. That means that x is minus 2 and x minus 2 equals 0. Okay, x equals positive. And we get exactly the same answer. Got it? In this crucial moment, we don't finish, but we have a lot of information. We have the rule. We put the all real number line that represent the x-axis. I plot the information that we have so far. So far we have, this is x. This is 0. This is infinity positive. And that direction, infinity negative. So we have only 0. 0 is this guy. We have positive 2. And negative 2 is the famous vertical acid. Vertical acid the 1. Vertical acid the 2. So when I finish this problem, I need to evaluate. I need to evaluate at one point here. que maybe it's 3. And 1 point here, que maybe it's 1. And 1 point here, que maybe it's -1. And another point here, que is -3. This is a minimum value. You want to select more, much better. To see more accuracy, the shape of the curve. But this is a minimum. So I have 4. 4 red point. If you are doing 3, no good. 4 is acceptable. Okay, now let's continue. Step 5. Step 5 is the horizontal or slant asset. Remember, they are mutually exclusive, no both, impossible. I want to start for the horizontal. Horizontal is degree analysis. Degree of the polynomial P, que in our example, the polynomial P is 4x. I 1 because it's linear. And degree of the polynomial Q, que in our example is x squared minus 4 is equal to. Wow, entonces now we have in front the case in which the degree of the polynomial in the denominator is bigger than. Entonces, yes, we have horizontal, but a special horizontal at y equals 0. Boom. And no slant, for sure. Okay. Do you follow me, guys? You understand very well the part? This is the confusing part for the students. The student need to memorize these rules, this degree analysis. Then. Bueno. When you find any horizontal, you need to determine the crossing point. Don't forget this, please. Only one, or no, or do not exist. So you take the original equation, 4x over x squared minus 4 equals 0. Oh, but this is equivalent to say 4x equals 0, no? Remember, that's p. I don't care the function, the top part. Because to be 0, we need only the top part would be 0. Oh, but I found before this. S and the X in a set. Also, the famous origin, wow, it's 3 things. Is Y in a set, X in a set, and also crossing point. Please don't forget crossing point. Okay, not always exist, but sometimes, yes. Now finally, step 6. Step 6 is the symmetry. Okay, maybe you see, I don't care, it's not important for me. See, it's important, it's important. Okay, you take the original function, que es f of x equal x squared over x squared minus, no, 4x, sorry, mistake. I just copy here. 4x, x squared minus 4, and you replace x for minus x. You are doing a reflection. Entonces es 4 times minus x divided by minus x squared minus 4. Oh, look at that. This is minus 4x, obviously, right? But this no, because this square stay the same, it's positive. Now, when you compare this equation and the original equation, you see que, oh, it's similar, except que es opposite sign. In other words, it's like f and x is equal minus, or f and minus x, sorry, is equal f and x. It's a typical odd function. And I take advantage because this is odd function. When you find a point, okay, for example, I don't know, okay, 1 something, 1,2. I don't know si it's this. I copy hypothetically. This is negative negative 1 comma negative 2. So opposite, the same value, but the opposite side. Okay, so with this information, we are ready to put together in the rectangular coordinate system, of course, you using decimals. Let me try to share the screen for the decimals. Let me see. No, this is number 5. Cool. Okay, there you go. I want to share the screen, guys, to see more clear, more clear. Switching to decimals. Rational function new. Do you see decimals? My decimals? Aha. Listen. The thing I try to explain, when the class is over, I will send the link of the YouTube. And also I send the link of these decimals. But when you receive the link and you open, this is my gift. I give my copy. But you can modify, delete, destroy. My copy stays the same in my computer, no? It's just share. And you can include another thing if you want, no? For example, in the example number 5, the example we are doing here, okay, is 4x over x squared minus 4. Bang! I did that. Let me try to understand this. Look. We have the famous point 0, 0. This famous point 0, 0 is number 1, y and z. Number 2, x and z. Number 3, crossing point. Because we have one horizontal asymptote that is at y equals 0, this one. Let me flash it. Look, do you see the flashing? This is the horizontal asymptote, sorry. And this is the point in which the curve in blue color crosses the horizontal asymptote. And we have 2 vertical, look, 2 flashing and negative 2 flashing. This is the collection of the asymptote, 2 vertical and 1 horizontal. And the typical point you assume either way. Okay, listen, it's easy because you using function notation in decimals and you copy any name. I copy f1 x. You can evaluate any point. How you can evaluate? Let me show you how. You can evaluate, for example, you copy in another extra line I want to create now. We copy the point, 1 comma something to say you can plug it in, put it in the calculator. But no, you put f1, evaluate n1. Okay, and now you see, this is a this is a label, no rótulo, okay. But you don't see the value. Oh no, yeah, you see the value. The value you see que es in red color, no? Negative 1.333, que es negative 1/3, or 4/3. Look, I copy here, 4/3. Guys, do you follow me? Oh no. Super easy, super clear. I know that this is advanced mathematics. No super, no calculus, pero es pre-calculus. But don't expect in my subject is okay. Never. Do you follow me? Yes or no? Come on. Question. This is a moment to. Clear. Shane is clear always. Shane was my student in trigonometry. Excellent student. Entonces, some students, guys, que finish with me, pre-calculus, we can connecting forever to when you take calculus, you want to take calculus, I work as a tutor in the STEM lab. Okay? I have my pleasure, at least the day I working is not every day. You come here, yeah, I sit to you in calculus. Calculus is another big legal. It's another thing. Okay. Entonces, we have time, we have 10 minutes. Let me try to at least to see one more example because we have the methodology. So the guideline I want to send also. So I need to send in the email things. Number one, the link of the video. Number two, of the link of the decimal. Number three, the picture. Okay, state the guideline, the 7 step. 1, 2, 3, 4, 5, 6, 7. Okay? Okay? Switching to whiteboard. Microsoft whiteboard. Do you see my whiteboard? Let me erase everything. Yes or no? You see or no? Wow. Yes or no?
Yes, yes, yes.
Okay. Okay. Next example. Suppose example 2. Of course, a strong example 2 can include everything. G of x is equal to 2x squared minus 3x minus 5 divided by x squared plus 1. Okay, help me. What is the step 1? I don't remember. Who refreshed my memory? Who is step 1? What is the step 1? What is
Factorization.
Factorization. Very well. Let me try to do my best. This is trinomial on the top. X squared. X squared, yeah, x squared. X squared on the top, x squared on the bottom. Now I take the polynomial on the top. I do the factorization. Well, let me try to do it my way. You multiply 2 times 5 get 10. And the combination obviously is 5 and 2. Because 5 times 2 is 10 and 5 minus 2 somehow is 3. So you copy 2x squared minus 5x plus 2x minus 5. I convert my trinomial and polynomial because I want to apply factorization by grouping. And the couple blue and the couple red first. The great common factor is x. In the couple blue, we have no common factor. The reason is 1. Now, finally, the factorization is 2x minus 5, parenthesis, x plus 1. Yeah, I replace that. Look. This is 2x minus 5, x plus 1. And the bottom, x squared plus 1. Do you understand very well the factorization, guys? You are doing it your own way. I am doing it that way, okay? I consider better, at least for me, in my mind. So you are doing using trial and error, there's another possibility, it's okay. You get the same answer, beautiful. But in the bottom, x squared plus 1, I saw, wow, this is prime expression. How do you know it's prime? Because of binomial and no differences. Yes, x squared minus 1, oh yes, the factorization is pretty easy. There's x, 1 plus or minus, apply the famous formula of the difference of squares. But this is sum of the square, no. No, it's prime, it doesn't stay the same. It's prime expression, sum of the square. Do you remember this or no? No problema. No problema. Everyone remember that? Step 2. What is the step 2? I don't remember. Yes, Jose Cabrera, he said yes. What is the step 2? I don't remember. What is the step 2? I don't remember, guys. Help me. Y-intercept. Eso, Y-intercept. For finding Y-intercept is easy. You take the function, que by the way, the function is g, and evaluate 0. Oh, it's easy. Because the only guy can stay alive in the bottom is negative 5. And the only guy can stay alive in the bottom of 1, so it's negative 5. And the famous point is the point 0, negative 5. X value, Y value. No problema. Everyone follow me? Entonces let's move on to the step 3, que es X, always more complicated, always more complicated. S g of x equals 0, get much better, in my opinion, is P of x equals 0. And P of x in our example is the original trinomial, but much better, in my opinion, you copy the factor 4. Okay, so now it's easy. Investigate what is the 0 of that polynomial. You take 2x minus 5 equals 0. This is 2x equals 5. By 2 is x equal 5 over 2. And the point is 5 over 2, comma 0. Likewise, x plus 1 equals 0. X equals minus 1. Okay, the second x in a set is negative 1, comma 0. Any question, guy? What is the step 4? I don't remember. What is the step 4? I don't remember. Who help me? Don't remember.
Vertical asymptote.
Very good. And very good acid, what is the formula? The formula is you take cube x equals 0. But who is qx of x in this example is x squared plus 1. Oh, it's a quadratic equation. I solved in this quadratic equation. But when I try, suddenly happened this situation. X squared equal negative 1, apply square root both sides. X is equal plus or minus I, because the square root negative 1 is I. And it's illogical, because the reason that this expression is prime is because in the real field it's impossible the factorization. However, yes, it's possible in the complex field like that. X, I, positive and negative. When you are doing this multiplication, you get the answer. Let's do it quickly. X times x is x squared. X times minus I is minus ix. This time this is plus ix. And this time this is minus I squared. This is cancelled. And this is x squared plus 1 because I is squared and negative 1, but this negative 1, another negative 1 that we have in the front becomes. It's logical. So now, if you determine that the value is complex or imaginary, it's because the vertical asymptote do not exist. Because you try to, I don't know anything. I try to do my best. You set out the equation. The equation give me, this is a classical, guys, in algebra. You don't know something. Okay, no problem. You set out the equation. So you try to do your best in algebra and you get complex or imaginary is because in the real field, this solution that you try to find do not exist. So actually, in this example, our rational function have no vertical. Okay. Keep in mind this. Now, step 5 is the classical step que we analyze horizontal asymptote or slant. What do you think doing the degree analysis in our original problem? Let me copy the original problem. It's 2x squared minus 3x minus 5 divided by x squared plus 1. Remember, answer to question. Number 1, we have yes or no. See, the answer is no. Okay, I finish. See, the answer is yes. We have the second question. Is at what value? What happened, guys? Are you tired? Are you tired? Answer that question. We have yes or no. Remember the degree analysis. What is the degree? You ask by yourself. What is the degree of the polynomial at the top? What is the degree of the S?
We have one.
Say again?
2.
2. And what is the degree of the polynomial at the bottom?
2.
2. And what happens when you have the same degree? Yes or no? Yes or no?
Over 1.
Yes. Yes or no? Yes, right? I don't hear very well. Everyone understand a yes? Yes, what?
Yes.
Yes, we have horizontal. At what value?
2.
2. Very well. At 2 case, the answer is yes, we have horizontal asymptote at y equal 2. Because there's 2 and here is 1. 2 over 1, of course, 2. And what about slang? We have slang or no? No slang? Yes. No? No, yes. Come on, guy, I don't hear. Almost the time is over. No, of course no, because you have horizontal, you have no slang. Okay, now let me finish. The rest is determine the crossing point. We continue next time this example on 2 more examples. To determine the crossing point, you set out the equation. 3x minus 5 divided by x squared plus 1. You enforce it to be 2. You apply cross multiplication. So when you apply the cross multiplication, it's 2 x squared minus 3x minus 5 times 1 stay the same. 2 times x squared plus 1. Apply distributive property 2x squared plus 2. This is cancelled. And stay alive minus 3x. Equal 2 plus 5. Because I move a negative 5 to the right hand side like a positive. Get 7 then. Divided by negative 3 both sides. Okay, now x is equal minus 7 over 3. Entonces our famous crossing point would be at the point minus 7 over 3, comma 2. Because 2 is the y value of this. So yes, we have. And when you are doing the graph next time, Monday, you see the crossing point. Cool? Cool? Okay, no problem. Entonces we finish. Bye-bye. See you Monday. Monday, remember, I will send everything. Today I send 3 things. Video, Desmos, and the guideline picture. Bye-bye.